Okay, so we're going to be learning numerical data and bivariate numerical data. So we're going to go over this lesson and let's get started. So, in this topic here, you're going to learn to display bivariate numerical data with scatter plots. These are scatter plots down here, the X and the Y with the little dots. There are three of them down there. Okay, they model the data. You're going to model the data with linear equations. Remember, linear has to do with line, and equations are when you have numbers and letters with an equal sign. You can see the word line and equal in the word linear and equations. So you're going to do that. You're going to look at these scatter plots. You're going to make up equations with them. And then you're going to use those equations to make predictions like we've talked about before. Maybe you're an athlete and you're trying to increase in a certain area. You measure how many, you plot data based on how much weight um, you can lift, and then you make predictions about what you might be able to lift based on this data, for example. The so we're going to begin by constructing scatter plots and looking for patterns in the data. When you find these patterns, they're called evidence of association, but that association does not imply a cause and effect relationship like input output. They describe the shape of these patterns of association as linear or nonlinear. Remember, that's what we did last, is to differentiate between linear equations. Remember, if it's linear, it doesn't have an x on the denominator, it's not under the radical sign, it's not doesn't have an exponent. That's what we look for. And nonlinear, they are lines. By linear, they mean straight line, and nonlinear could be a broken line or a curvy line. And so you're going to describe the direction of linear association as positive or negative. If it's positive, if it has a positive slope, then it's going up. But if it's a negative slope, it's going down. Like if you get paid and you have to pay bills, then the amount of money you have in the bank goes down, right? And preparation for Algebra 1. So that comes next. You're also going to describe the strength of these associations as weak, moderate, or strong. Then you're going to build on your knowledge of outliers and clusters in univariate data. Uh, so outliers are, say everybody in the class makes an 80, but you make 100. You're like an outlier. You're not in the normal range. You're exceptional. Okay, so that's like an outlier. So for data and scatter plots that appear to have a linear pattern, see how that looks like a straight line going through all this, like you're connecting the dots, but not really. Uh you're making a line through the majority. Okay. Okay, so again, there's our line. To conclude the topic, you're going to return to the investigative process from grade 6. You're going to develop a statistical question that can be answered by collecting bivariate numerical data from your classmates by using skills and tools from this topic. Then you're going to collect, display, and analyze their data and present your results. Okay, so let's move forward. Okay, so for lesson 11, it's scatter plots. And the objective is to construct scatter plots and identify those that show an association between two variables. That's why it's called bivariate, like a bicycle has two wheels, right? Two variables, X and Y. Describe the difference between an association and a cause and effect relationship for numerical variables. Okay. So in this lesson, you're going to construct and interpret scatter plots for data for various t-shirt print shops. By examining an unorganized data set of two variables, students recognize a need for a way to organize the data. They then construct the scatter plots and recognize the advantages of representing data in a scatter plot. So you're going to learn what is a scatter plot, when is it advantageous to use scatter plots. Okay. After informally identifying patterns in scatter plots, students realize that these patterns do not imply a cause and effect relationship. This lesson formalizes the terms observational unit, so you need to understand these, bivariate numerical data, scatter plot, and association. So we'll be looking at those words. Some of the questions will be, why is a scatter plot useful when working with bivariate numerical data? What can an association tell us about the variables, and what can it not tell us? All right, so for the first part of the lesson, students plot points to prepare for constructing scatter plots. You plot points to prepare for the construction of bivariate. So remember, this is called the coordinate form 0, 6. Remember that the first number in a coordinates for a point, the first number tells you the x value. The first number tells you the x value, and the second number tells you the y value. Okay, so we plotted. It's not letting it stay there. Let's see if I can hit control. All right, so we'll just talk about it. You see 0.06 is the one. 0.06 is on the y-axis up there at the 6 point. 0.60 is on the x-axis, the one that is at the 6 on the x-axis. 2.6, you go out to 2 on the x-axis and up to 6, and you see that plotted. For 6.2, you go out to 6 and up 2. 3.3, out 3, up 3. 3.6 is out 3, up 6. Okay, so suppose we talked about small businesses before, like selling t-shirts, for instance, designing t-shirts. And select from a variety of shops in order to get a feel of how distances may relate to shopping times. It says, think about small business shops instead of large businesses. as they think about which variables may give information about how long it will take in order to reach a customer. So let's think about shipping time and the distances if you're ordering t-shirts. And so Maya is the person who's doing it. She's comparing the shop's distances from customers to the shipping time. Was it easy to keep track of the relationship between the distances and shipping time, and why? So it says, no, it was hard to remember the shipping time for each shop without selecting the shop again. Okay, because what they want you to see is they're not related to each other. It's random um which shop. Okay, so what's happening here is it's talking about Maya, and it says the Maya designs shirts. She needs to choose a print shop that can print and ship the shirts. Her customers want their orders as soon as possible. So Maya gathers shipping times and other data for several different customers. In this lesson, shipping time refers to the time when the customer places an order to when the item arrives. Which variables can you use to predict how long it will take an order to reach a customer? The shop's distance from the customer, the cost of shipping, the shop's customer rating. So she's trying to see which ones have the best shipping times. Maya wonders whether the distance from a shop to a customer is related to the shipping time. Select a shop to view the shipping time. And um, the shipping time to a specific customer and explore the relationship. So you must be able to click on it and it tell you. I'm not getting the permission. It's not letting me do that. Okay. But I think that's the goal, that it be able to do that. So, okay. So let's move down with that understanding. Okay. So the whole point of that activity was to show you that you need a way to gather that information so that you can remember it. You can't remember it so easily unless you click on it again. That was what you were supposed to get from that activity. It says, was it easy to keep track of the relationship? No, it's hard to remember unless you select it again. And it might be easier if we have to analyze the data, if we have a tool to organize it, which is all about while we're doing uh, the scatter plots. That's the tool they want you to learn with this. Okay. So promoting this. So what you're going to be asking yourself now is, what does each data point mean in the context of a shop's distance from a customer and the shipping time? And how does a scatter plot represent the observational units? What does a pattern and a scatter plot tell you about the association between the shipping time and other variables? Okay, so here's Maya's data. Shop A is 125 is 125 miles. Shipping time is 4 days and so forth. So you would plot that. 125 is the A. That's 150, right? So that's 125. And that would be 4 days. So you would plot shop A right there. Shop B is 200 and then 3. It's right there. Shop C is 275. 275. So that's 250. That's 275 and 14. 307. 425 and 10. 450 and 5. So you see how I am plotting it. That was this one right here. Okay, now let's go back. So first we talked about Maya and how they're not related to each other, the shops, and why it takes the time it does. They're random points. And so it's not cause and effect. And then she needed some way to remember it. So you can see a pattern in the scatter plot. So it says Meyer wonders whether the shipping cost is related to shipping time based on the scatter plot. What do you think? To Maya's question. Okay, so you can see a sort of pattern that the farther there's somewhat of a pattern here. This one looks like an outlier. It's not in part of the pattern. So these are an association. It's not cause and effect. But you see a pattern that the farther away you get from the farther away the customer is from the shop, the longer that it takes, right? Okay. So, okay. So here is where they've presented the data. Here is where she gathers the time, the distance and shipping time. Here is a scatter plot. Okay, so her next question is she's wondering if the shipping cost, which now we have here, is related to the shipping time. So uh here we do see, and she says that she sees a pattern. So she's gonna plot the shipping time, the shipping cost, and see if uh and this isn't cause and effect again, it's just association. And she's going to see if she sees a pattern. So she's going to plot that. And it says she wonders whether the shops with more shirt color choices have shorter shipping times. So she gathers data for a different customer's location, and the results are shown here. So for this one, I don't see that she plotted it. Let's plot some shipping cost and shipping time. For top A, the shipping time was 4 days. Shipping cost was $4. For shop B, shipping time was $3. Shipping time was 2 days, and shipping cost was $3. For shop C, the shipping time was 6 days and then $4.50. Okay, shop D has 4 days and $5.50. Okay, shop E, 3 days, 3 days and $6.50. Uh, 3 days, $6.50 right here. Shop F, 5 days. Wait, I did $6.50 wrong for this one here. For shop, for this one here, it's, yeah, 3 days. 3 days here at $6.50. Let's go back and make sure I did this correctly. So you've got $4. The first one was 4 days, $4. The second one was 2 days, $3. The third one was 6 days, $4.50. Then we have 4 days, 4 days, $5.50. 3 days, 3 days, $6.50. So that's this one right here. Okay. 5 days up here. 5 days was $7.50 out here. So shop G. So you see an increasing relationship. You do see a pattern with that. Okay, so it does increase the shipping cost does seem to increase with the amount of time that it takes to ship it. So she figured out that relationship. Another question is she wants to compare color choices to shipping time. And do you see a relationship there? So what about farms in town and where a print shop is located? So you can see when she plots it, that does appear to have a relationship. This one does not. It looks pretty random, right? The relationship between farms in town to shipping town time does seem to have a relationship. This one also seems to have a negative correlation. Number of restaurants within 5 miles with shipping time has a negative relationship. Maybe the shippers are eating, stopping and eating a lot, and it's taking them longer. She wonders whether there's association between average customer ratings and shipping times. So we're not given the data there. So here it tells us shipping time and customer ratings. So the higher the customer rating, well, the higher the shipping time, the lower the customer rating. That would make sense, right? When you order something, you want it to come there quickly. Okay, so those are all the examples of her data, and then we're going to complete an exit ticket. Okay, so the last part of the lesson is the table shows the number of points scored and the number of rebounds for each player. Okay, um so you're just going to plot the points right here. Number of points you see is the X down here, right? So number of points, that's the X, 18. Number of rebounds is the vertical, it's the Y, and that's 10. So there should be a point at 18, 10, which there is. And then they ask you questions. Do you notice an association between the number of points scored and the number of rebounds? Yes, players who score more points also tend to have more rebounds. No, an association between the number of points scored and the number of rebounds does not mean that there's a cause and effect. Yes, yes, it's true that there's an association. You find that players who score more points tend to have more rebounds, but it's not a cause and effect. It just happens to be that there's an association.